think I did it right.
Yeah, because can I see yours again? Because I keep looking at your paper and I'm like, oh, I have that. Yeah, right over.
All right, guys. Let's see, any consensus on what the hardest problem was? What do you think? What was the hardest problem?
2A.
2A. There's a vote for 2A. Anything else that you thought was the hardest one? No? You're all like, they're all equally F.
One F?
They're all kind of.
1F. Okay, we'll take a look. All right, so let's take a look. What is the idea behind 1A? What is PEMDAS? Is there like a saying for that?
Yeah.
That's right. Please excuse my dumbass son. That's right. Or I prefer that one. Because sometimes I have somebody in class who's like, yeah. But also one time a class came up with this. Yes, not me. Please excuse my deficient algebra skills. That also works. Now, here's the thing. I was talking to another group. I've actually heard math teachers say multiplication comes before division, which if you thought that was true, that is so not true. So people write it like this. We could have written it like this. Which one is easier to say? Say this one and don't sound drunk, right? That wasn't me, officer, it was Petbershaw. So, does some of you guys understand what my point is here? Because multiplication, division, you do it as it comes. Addition, subtraction, you do it as it comes. So here's the right way to write this. Parentheses first. No question about it. If there's something inside the parentheses, that's immediately the first thing you do. Then exponents. Then multiplication, division, as they come. Neither one is more important than the other. They're equal footing. And addition, subtraction as they come. Now, let me ask you this. I'm going to say this. Tell me if anybody's okay with what I'm about to say. There is no division. Division doesn't exist. We made everything up, but especially division doesn't exist. And there is no subtraction. Division is multiplying by the reciprocal of something, yes? Yes? You remember that part? How do I do 8 divided by 1/7? Isn't that 8 times 7? Do you guys remember that? Yeah. And I could talk about it right now, but we will, especially later this semester, we'll talk about, I'll prove to you why that works. Why you multiply by the reciprocal when you're dividing fractions, okay? So these are actually the same operation. So of course one shouldn't come before the other. They really are the same. And let me show you another example. If I had 4 divided by 2 times 5, this is trying to be divided. If you think that's 4 divided by 10, that is so not fair. What is the only number that's being divided in this problem? What's the only number that I'm dividing by in this problem? I'm dividing 4 by something. What am I dividing by? 2. Right? In fact, how do I rewrite 4 divided by 2? Is there another way to write 4 divided by 2? 4 over 2, yes? Yes? All right, so this is 4 over 2 times 5. So if you think this is 4 divided by 10, how the hell did you get that 5 to go down? You just push that 5 down there? Right? Leave the poor 5 alone. All right? So it isn't fair to divide by more than what you're supposed to divide by. You're supposed to divide 4 by 2. You get 2 times 5, 10. Done. Not 4 divided by 10. No. The reason people think division comes last is because if I have a problem like this, I don't know. Right? What would you do last? You would do division last. But that is because when I draw a big-ass division bar, there are understood parentheses that come with it. We just don't write them because why would we? That's wasting ink, right? But then we forget. We're like, oh yeah, shit. So division is not always last, but I think it's these kind of problems that get in our head and we go, oh yeah, division's last. No. Okay, maybe. So let's come back to the actual problem, Jeff. Yeah. So, with all that said, what do I do very first thing?
Subtract 4 from 2.
Well, subtract 2 from 4. Okay, so what do you get in there? You get, amazingly enough, okay. Get 2. Okay. So you gotta really fight yourself to not write 6. Yes? It's divided by 2, so the 2 is actually on the bottom. It's not up there with the 3. There's no way it can make 6. Maybe. Then what's next?
The exponents.
Exponents, so 2 squared is 4. What's the last thing we're gonna do? What's the last operation we would do? You would know that from the very beginning, because why? Because it's at the ass end of PEMDAS, yes? So you do it last. I'm really sorry. I got bad jokes. I cuss. If I offend you, wait a minute, I'll do it again. So here, I kind of ignore that for a minute, and we just did a problem like this. So what's the right way to do this problem?
4 divided by 2.
4 divided by 2 is?
2.
2. It's crazy. And then 2 times 3? 6. And then you get that. Right? Sweet. Maybe. Okay. So this is the kind of thing that I teach in my algebra class, but you guys, you need to realize these are the kind of things you want to keep an eye out for when you discuss these things with your students, and if students are doing it. Because again, they're going to get help from parents, they're going to get help from friends, and the friends or parents could say something. You want to watch out for some general misunderstanding like that, right? And you want to be one of the teachers that teach this thing correctly, dear God, right? Right. Okay. What's the idea here? What's the very first thing I should do here?
Distribute the.
Yeah, cool. So your eyes should kind of, after you've gone through some algebra, your eyes naturally go towards distribution stuff first, hopefully, right? So of course, when you do that, you get, what do you get?
2x plus.
Minus 2x, yeah.
Plus 2, 10.
Plus
10 1.
10 1, I like it. And now what kind of problem is it? What kind of problem is this? Yes?
Well, I'm not sure. I was gonna say combine like terms.
Yeah, like terms. There you go. That's what I want. I don't know what you want from me, Jeff, but yeah, this problem is now just a like terms problem. I got 5 x's over here. This guy took 2 away, so now how many x's I got? 3. So I got 3 x's. 10 y's, I took 3 of them away, and then I gave myself 10 more. Right, so 10 and 10, 20. Minus 3, 17. Coolness. I like it. Okay, I like it. And again, some of you guys might be out there going, holy shit, this is easy shit. So don't worry about it. Today is just sort of like, and some of you guys are out there are like, I don't remember this stuff at all. All right. Today is just sort of like shaking out some rust, seeing where people are. The main thrust of this course will be talking about how to teach these ideas. I will somewhat assume that you know them, but we will review them when we hit them, right? C is really interesting. Did anybody do part C in multiple steps? Yes. It's a very common thing. Sort of? No? Okay. All right. So before I tell you a way you can look at these kind of things, can somebody tell me what did you do first if you did multiple steps?
I divided by 12.
By 12. Okay, because you just happen to notice 12 goes into both.
Yes.
Okay, I like it. So when you divided by 12, you got
4 over 6.
4 over 6, and then it was easy to
Divided by 2.
11. There's not a damn thing wrong with that, right? It's beautiful. Anybody do this in one step? Do you know why, or did you just sort of realize it worked, or?
I just divided by 24 because I knew they went into both.
Oh, okay, cool. I like it. Watch this. This is so cool. This doesn't always work, but it's the first thing to look for when you're looking at a fraction. This one's not that bad, but any big ass fraction, you're not sure what to do with it. Before I say this, if I count by 3s, 3, 6, 9, 12, blah, 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 isn't any multiple of 3 a multiple of 3 away from another multiple of 3? Does that make sense what I'm saying?
Yeah.
6 is how far away from 12? It's 6 away, which is 6 is a multiple of 3, yes? So any multiple of blank will be a multiple of blank away from another multiple of that blank. All right, that's a weird ass sentence. But so, watch this. How far apart are these two numbers?
24.
24. 24 might go into both, because if I start counting by 24, everything I do is 24 apart from each other, yes? And if 24 doesn't go in, then the only other possible thing that could go in are factors of 24, like 12, or 2, or 4, or whatever, right? So if you try to divide by 24, what's 48 divided by 24? 2. And 72 is one more 24 up, so of course it's frickin' 3 when you divide that by 24. You guys see that?
Yep.
Okay? Okay. So divide by 24, divide by 24, you get 2/3. Bam! Okay. Jeff, calm down. All right. Sorry. Now we hit a row of problems that I noticed that was blank for a lot of people. And I'm not saying anything bad. We got a whole chapter of just fraction stuff later, and you're like, oh, good. But we can really try to address some issues. Does anyone think they got this one done correctly? Can you explain what you did?
What I remember is I had a teacher who said essentially every whole number is just, in this case, 7/7.
Ooh, okay.
So,
Ooh, look at
get
that.
rid of
Jumping
the whole
straight to
number.
the neat way to do shit. Go ahead.
Get rid of the whole number, and
Sorry, I'll calm down. So,
essentially it becomes 9/7 or 3.
Yeah, yeah.
And
so let
9/7.
me set the stage. I love this. Let me set the stage for everybody. Right? Does anybody kind of catch what he's saying, or does that, or you're like, I have no idea what he's? Okay. Okay. So watch this. This is so cool. This idea of borrowing works for more situations than you know, because it's a broad idea. The place we use borrowing the most is something like this. Jeff, what are you doing, buddy? It'll still work. All right. Like, let me make a problem that borrows. I'm like, damn it. Anyway, I managed to do it. Good job, Jeff. So to do this fully by hand, you of course would have to borrow. Now here's really kind of evil, right? This is smaller than that, so you can't subtract. So you look here and you try to borrow, and then of course that's going to lead to other problems, correct? So if I borrow, now what happens? Let me just do the first stage of this. If I borrow from that, what does this 3 represent, of course, really? 30. So if I take a 1 away from it, I'm actually taking 10. And that's why I'm allowed to put the 10 I took from him onto this guy. Yes?
Yeah.
That's all that is. So everything here represents a 10. So if I take one thing away from him, I can actually put a full 10 on top of that one, and I don't care about the rest, right? So let's go back to this problem. Sure, Jeff, we'll do it right on here. So let me write this down here. 4 2/7 minus 2 5/7. Is that what it says? Yes.
More to the left.
Oh yeah, you should probably be able to see this. Yeah, I'm gonna not use this projector much because I don't like them much. I'll be on the board more. Either way, my handwriting won't get better, so sorry. So here's the idea, exactly the same way we did a minute ago. I can take 1 away from this. And just like you said, isn't 1 7/7? Just like the 3 actually meant 3/10, yes? 1 is 7/7. So then when I put it on this thing, it would become 9/7. So I borrow 1 from this 4, and then I put it there. So that becomes now 3 9/7. Now, if you are going to say, well, Jeff, that's not allowed. You're not allowed to do that. You're not allowed to write a 9. I know that. I know. Well, you're not you're not freaking allowed to put freaking 18 in one place either, are you? So is that really what we're doing? No. We're rearranging so we can do it easier. That's it. Same idea. Exactly the same idea. So now this is easy as hell. Yes. 3 minus 2 is 1. 9/7 minus 5/7. Thanks, everybody. All right. So, did somebody else do it a different way? Yes.
I remember that we could multiply the denominator with the whole number.
Oh.
And then add the numerator.
Yeah. So you changed it to an
30.
improper fraction, right? Okay, and real quick. All right, so just get used to this semester. I go on a lot of tangents, but they're useful tangents, is my hope. This, to be really honest, mixed numbers are one of the most evil notation conventions we've ever come up with. Does anyone know what I mean by that? What does it mean normally? Like, what does it mean when I write 3y? What does that mean? 3y, bam. What does that mean? What is the 3 and the y doing? Multiplying, right? Yes? Something sitting next to something else. The convention is it's multiplying. So does this mean 4 times 2 7s? Shit, no. What does it actually mean? 4 and 2 7s. So what operation is there really? What operation is there really? Addition, right? Isn't 4 and 2 7s 2 7s more than 4?
Yeah.
So it is 4 plus 2 7s, literally. Right? I don't know what other notation we could have used, but that sucks. And little ones learning this stuff for the first time are really going to have some issues with it because it's not going to be a universal thing, right? Okay. Oh man, it's far over. So real quick. I'm going to show you where that shortcut comes from, right? So this actually is 4 plus 2 7s. And isn't that 4 over 1 plus 2 over 7, yes? And real quick, can you add x plus y? No. So if I said simplify x plus y, you would look at me and go, I was done before you asked me. That's what it is, right? So anytime I'm adding, subtracting anything, they must be like terms to be able to put them together, correct? So I got 4 1s and 2 7s. 2 7s, right? Not like terms. But I can make this like term. And of course, you know what to do. We're just trying to tell you why it works, right? So what do I do, of course, here? So I can add these together.
Multiply by 7.
Multiply by 7. And let me put over here, when you do 7 times 4?
Yeah.
First step to do it? And isn't that exactly what we just did? And you get 28, and then what would you do next?
Add the 2.
Add the freaking 2, isn't that what we would do next? Right, okay. I just make sure that you guys really understand where shortcuts come from. What's most important is the idea behind a shortcut. I've seen way too many teachers teach the shortcut and that's it. And that makes students feel good, they get the answers, but they don't have any foundation to build other shit on top of. And math is all about understand this, build more on top of that. If this is like crappy, yeah. Anyway, it's a horrible example, but all right. So if I keep going, so let's go back. So 4 and 2 7s will be 28 plus 2 37s, yes? And what happens here? Oh, I'm sorry. There we go, okay.
I do the same. Multiply and add.
Yeah, you get 14 plus 5, 19 7s, which is
11 7.
11 7s. And then how do I make that into a mixed number?
7 goes into 11
Once with,
4 over 7.
I like it. Now real quick, I want to show you this. This doesn't really change any work, but it does change how you look at something. Why does that suck? Why does that 11 suck? Because I can't divide it by 7 evenly, right? If it was 7, it would be amazing, yes? That would be so kick-ass. So let's just put a 7 up here. But is that a 7? No. Isn't it 4 more than 7? What's 7 divided by 7? 1. What's 4 divided by 7? All right, right? And that's not like amazing, David Blaine shit, but that's just a different way to realize what you're really doing. And that's a different way to realize what the hell remainders actually mean, yes? They're just how much above something you are that would go in evenly, yes? Okay. Why am I rushing? Almost something. Yeah, we get plenty. So this one now, all right, now why is that one a little worse in a way than the other one? Because the other one was like a 1 on the bottom, and that's easy. So, but so if anybody said 4 over 4, right? Now think about it, from one perspective, can anybody tell me if somebody did this problem, you guys see where 4 over 4 comes from? And 4 over 4, of course, is 1.
Yeah.
Can you see something very quickly to tell, oh, there's no way it's 1? Can anybody see how you can just really quickly tell there's no way that's going to come out to be 1? You just know it just by looking at it. 1 makes no sense. What's 11/12? Is that bigger than 1?
No.
Smaller than 1, right?
Yeah.
And aren't you taking something away from it?
Yep.
So shouldn't the answer be a decent amount lower than 1? So if you get 1, you know you're wrong because you started with less than 1 and took some shit away from it.
Yeah.
Okay, maybe. Now, 12 and 8, not that hard. Those numbers, right? What's the LCD? 24. I like it. We'll talk more later this semester about what if the numbers are worse. What's a nice way to get the LCD? Let me kind of show it to you right now. These are really simple numbers, but can somebody tell me what number 8 and 12 has in common? 4, right? 12 is 4 times 3. 8 is 4 times 2. And now that I did that, I know that this guy is missing a 3. And this guy is missing a 2. So you multiply this by 2, multiply this by 3, and that gives you 24 in the bottom, right? Okay. So you give this guy 3, give this guy 2, 22 minus 21 over 24, which is remarkably enough 1 over 24. Is that cool? Now, something came up with part F that I want to address. What's the only time? It's all good. Oh, is that like a watch, dude?
Yeah.
Okay, sorry. I'm waiting for the Google shirt. Google shirt. What's the only time you would ever use cross multiplication? Does anyone know? There's only one situation where cross multiplication directly works. Does anyone know? Yes? Sort of. Because you multiply the reciprocal, so you can kind of argue, but no. Here's the one situation. Right? That's it. That is it. And it's actually a shortcut. If I multiply by 7, isn't that side not a fraction anymore?
Yeah.
And if I multiply by x, isn't this side not a fraction anymore? Doesn't it look like the x just came up? Doesn't it look like the 7 just came up here? So cross multiplication doesn't even freaking exist. It's just a shortcut to that. So that's the only time cross multiplication works directly. Now I keep saying directly because you can actually use it in creative ways in other places, but you have to balance it out. It's weird. That's the only place it will directly work. And I gave an example to another group. They asked me about this, and they said, do you cross multiply? And then I, of course, being a jackass or a teacher, I said, what's 7 times 8, right? Of course, they looked at me like, what the hell do you want from me? So what is 7 times 8? 56. And so isn't this the same question? Aren't they fractions? So how do we multiply fractions across? We know that. Otherwise, if we did this all of a sudden, then it's not 56 anymore, and that's not possible. 7 times 8 has to be 56. Okay, so what does all that mean? That means I'd have to multiply across, and that would so suck. Because then at the end I have to reduce, and I got these big-ass numbers, right? So why don't we just do the same math, just in a different order? Why don't we reduce first? Right? So let me show you a little more work than you normally have to show yourself. Looking up and down, I don't see anything in common. But looking diagonally, 15 is 5 times 3, right?
Yeah.
You don't have to write like this, but and 20 is 5 times 4. 20, and you'll see this again, 21 and 28 are 7 apart, and sure enough, 7 goes into both. 28 is 4 times 7. 21 is 3 times 7. So now what cancels? The 5s and the 7s. Do these 3's cancel?
No.
Hell no, because they're multiplying. They're not opposite operations. They're not one on the top, one on the bottom. Like it. So then you get 9 over 16, right? Is that all right? Yes, okay, sorry. By the way, what's really neat to me is when I teach this class, I can have different conversations with you guys on the same problems I teach all the time, because I can talk to you as somebody who will in the future teach. And what's really funny is when you're doing examples and you're doing work, you know, it's really kind of weird to go, oh shit, did I do that right? You're like, oh man, because you're so focused on explaining and writing, and sometimes you're like, I did 4 times 4 is 8, holy shit, or something, you know? So I try to tell my students, I've had teachers that told me they are the teacher, they don't make mistakes. And when they make a mistake, they get all angry. And I'm like, what good is that? So I'm like, I'm human. I make mistakes all the freaking time. If you see me make a mistake, just say, Jeff, man, what? No, here. Okay. I don't think I made a mistake yet, thankfully. 2A is a really good example of how evil the English language is, right? If anybody learned English after a different language, you know better than us that English is evil, right? In fact, some of you guys probably speak English better than those of us who grew up here. So this is a really good example of the evilness of English. This is not a problem math has.
Yeah.
If anybody thinks the answer to this is 2, it's not right.
Minus 2.
Yes. 5 less than 3 is 3 minus 5, right? Because if I had 10 things and somebody else has 5 less than me, then they have 5 things, right? 10 minus 5, not 5 minus 10. So there should be 3 minus 5. And real quick, just thinking, like I said, a lot of different math backgrounds out there. And unfortunately, a lot of school systems let students use calculators way too early. Holy shit. But the quickest way to do this kind of problem, the 3 is positive, the 5 is negative, right? So when the signs are different, you subtract them. 5 minus 3 is 2. And you put the sign of the bigger one on the answer. Done. Right? Another way to look at it, 3 minus 3 is 0, so minus 5 is 2 further down, so you're down 2. If I owed somebody $5 and I had 3, I still owe them 2. Yes? Everything I'm doing is coming out negative 2. Okay. Money is a good one because in grad school, this is what my bank account looked like a lot. And then when that happened, they're like, we have to charge you. I have no money. Charge away. Have a great time. So what about part B? What does product mean?
Multiplication.
Multiplication, right? What's the word for division? What's the formal word for division? Starts with a Q. Quotient. I love it. So 2 more than the product of 9 and 8. How do I write that? Okay, so 2 plus 9 times 8. And then, of course, good old order operations is always there. So 2 plus 72. Jeff, what is that? 74. I like it. Okay, cool. And then, did anybody look at that one and think that was easier than some of the other ones? Oh, because this is so drilled into us, right? This kind of thing is so drilled in that we forget shit like PIMDOS and all that kind of stuff because we're so focused on this. And again, where do our eyes go first? Parentheses, because that means I have to distribute. 4x minus 2 equals 2x plus 2. You can make whatever sound effects you want. And then I just gotta put my like terms together. And then the whole idea is get x's on one side, numbers on the other, correct? So I would take the x's that way so they stay positive, right? So I would subtract 4x. And since I'm doing that, since the x's are going that way, I want the numbers to go the other way. So I get 1 is x is 1. So a little bonus problem. Let me make a little bonus problem related to what we just did. All right, John, let's do it quickly here. You can do it, bud. There we go. Great stuff happening. Yeah, I like it. Okay. Little bonus problem. Little bonus problem. Make sure it's right, Jeff. Yes. Okay. Beautiful. There it is. Hopefully you can read that. Some scribblings of a man. Somebody think they got it figured out? By the way, I really like my profile on this mask. Anything weird happen on the way to solving this thing? Some weird shit happen? Okay. It's basically the same problem we just did. You got to be a little careful about this, right? I get 4x minus 2x. What do I get here? Plus 2. Oh, so I get 2x minus 7 equals 2x plus 2. So when you do this, and you could have moved the 7 over also. What the hell? What? So, anybody get to this point? Or did anybody do this and then keep it x? I love it how students are like, God, I hate letters and I hate algebra and all that shit, but then when the x wants to die, you let it stay alive. You're like, come here, x. Somebody's always with the x. I'm like, they died. So, stay with me for a second. What did this exactly mean? What is that answer we got? Don't just say x is 1. What does it mean? Does anyone know what that answer means? What are we trying to figure out from the beginning?
What's
What
the
x represents?
what's the value?
What the value of x is that would make this equation true. Yes? So when is this equation true? When x is 1. All right, now in that same idea, what does this mean? This equation is true when negative 7 equals 2. So is this equation ever true? No. No solution. I like it. So again, not math's fault. We just had a bogus equation to begin with. I can't double something and take 7 away and get the same thing if I double something and add 2 to it. That's impossible. Yes? And that's all this means. At the end, it's like, all right, that equation's good if freaking negative 7 is 2. And you're like, oh, it's not. Oh, shit. Okay, all right. So any leftover questions about anything on the sheet here? Oh, holy sheet. Okay. So what I want to do, what time is it, by the way? Oh, look at all the time we got. Oh, you guys are like, man. We're going to talk a little bit about chapter 2, just a little bit. And then we'll head out a little bit early. Don't get used to it. But if there's no other questions about that, okay, so we're going to get into chapter 2. Chapter 2, it contains some things that some of you guys might have seen, but it kind of depends on your teacher, if you've seen it before. Oh, Jeff, you can transition now, dude. All right. Okay, thank God. Okay, sorry. Just really hate the projector. What did I do? Okay. This is the most exciting part of class. Okay. That should work. I love this. So section 2 starts talking about sets. So you probably have seen notation like this. Let me make it official. That's me. Let me see if I can make it nice. There we go. Look at that. That's beautiful, Jeff. Good job. Oh my God. All right, let's try again. That's better. Okay. Right. So that is a set that contains 3 letters. Amazing. Yes. So the way we normally reference sets is by using capital letters. So I can say this is the set A. Incredible, right? I can then say A is an element of A. Yes. So this symbol here, has anybody ever seen this symbol here? So it stands for the phrase is an element of. I like it. So obviously this would lead to questions like, is 7 an element of the whole numbers? Right? So one thing we have to talk about is what the hell are whole numbers? What the hell are rational numbers? All that kind of stuff. So we're going to build our way there. But they don't have to be numerical. They could be letters, they could be words, they could be whatever. Colors. So what if I also said that set B is what, Jeff? B, C, F, G, Z. I like it. So is A an element of set B? Is little a an element of set B? No, so the way you'd say that is A is not an element of set B. Crazy. Is this familiar to anybody? You guys have seen some of this stuff before? Okay. So let me ask you this. Let me see, which way do I want to go? Yeah, let's do that right now. What if I said, can somebody list for me the letters that are in set A or set B? Now, let me tell you a little story. Because the other thing is going to be A and B. Yes? So I like to think of and or as two bouncers at a nightclub. Or is the nice bouncer. And is the mean bouncer. So for example, I go up to the nightclub. I'm like, can I come in? And and that's the and bouncer. And he says, if you want to come in, you got to know Joe, the bartender. I know Joe. Hey, Joe. And you got to be rich. I'm like, I teach. And I'm like, you can stop. And you got to dress nice. All right, well, shit. So I ain't getting to that place, right? Even though I met the first criteria, I can't get in. And anybody who's ever looked at scholarships have lived the and thing? So I remember back in the day, in the 90s, like in the before times, long ago, we would go to the scholarship, the financial aid office, and there was a book of scholarships. It's like, I remember this thing. It's like this. And every month they get a new one. I'm like, all the trees. Anyway, do it. You creep this thing open, and you look at a scholarship, and it says, you must be a math major. Yes. You must have this GPA. Barely. You must, and then the very end, and you must be this percentage American Indian or something. And I'm like, I'm only this percentage. I'm not that percentage. So I'm like, why didn't they put that first? So the whole list is and. All the requirements are and. So what does that do to the list of potential people that could get that scholarship? Shrinks them. So the and bouncer lets in fewer people. The or bouncer, so I come up to the door, right? And he says, to get in here, you got to be rich. Shit. Or, you got to dress nice. Shit. Or, you got to know Joe. I know Joe. Hey, Joe. And I'm in. So more people get in if it's or. Or more. Crazy. So this would list, holy shit, this would list anybody that's in either group, right? So what would be in there? A, B, F, good, C, G, Z. You don't have to list B twice, right? I can't go in the bar twice, right? Because I mean to, oh, I'm in and so am I, and holy shit. Okay. Is that cool? So the or, I like the symbol for or, because it's like you or you, somebody do it, and that's beautiful. That's exactly the symbol for or, is like that. And looks like an A that's missing a bar in the middle. So this is and. So and means you have to meet all the criteria. So to end up in the answer for this, you have to be in set A and set B. This is sometimes called the intersection. So it's sometimes easier to think of that. Where do these intersect? Where do these agree?
B and F.
B and F, and that's it. That's the only people that can get into this bar. Is the BFFs. I like it. Okay. Yes.
Would those, just because I'm going through the book,
Yeah.
would those also be subsets?
Oh, subsets. So we're going to talk about that. So I wanted to build some sets, and then I'm doing a little shit with them. So let me build some more sets and talk about some more stuff. I got to keep an eye on. I need to hire a video person. Video killed the man. Okay. So what if I now also include two more sets? So let's see. C is the set. You could do it, Jeff. CZ. I like it. And D is the empty set, meaning it has nothing in it. So does anybody know how to denote an empty set? What's the most obvious? If that's the set that contains A, B, F, how would I denote an empty set? When I just put those and have nothing in it, yes? Does that make sense?
Yeah.
So one way to denote an empty set, holy shit, somebody sat on that one, is like that. There's another notation. Does anyone know the other notation for empty set?
I don't want to cheat because I got the book, but it's fine.
Go ahead.
The cross,
Yeah.
cross zero. Cross zero.
And some people write zero like this, which I'm gonna, if you do, I'm gonna say careful because this means something different. This is not zero. This is specifically the empty set. What am I drinking? Right? So be careful. Okay. So, I can ask you, what do you guys think about this question? Is set C, is that a subset of set B? Is set C a subset? Sounds like she sells by the sheep. All right. Is set C a subset? And this is how you denote subset. This is one way to denote it, of set B. I know it looks like a little C, it's too bad. Let me make it more pronounced. That still looks like a little C, too bad. I know there's another symbol, but I'm going to stick with this. Is C a subset of B? What do you think that means? What's your gut tell you that should mean? Is that true? When I say subset, what should that mean? Yes?
Like a set within another set?
True. So this is really asking, does set C exist in set B? Does set C exist in set B? Yes. So this is true. This is true. And is set C a subset of set A? No. So this is amazing. We decided to say that is how you say whoa. Okay. I like it. Now, just to go one step further, this is a lot like, not a lot like, but it is a little bit like 7 less than 8, right? Do you see how that, if I make that less pointy, is this symbol here? When you say that set C is somehow less than set B, but it has more to it. Not just that it's less than, because it's not just the fact that it's smaller, because it is smaller than set A, correct? But it also has that idea of contained within. Okay, how are we all doing so far? But do you remember also that symbol? What's the difference between those two symbols? Yeah, it allows for the possibility that it's equal to, right? So therefore, geez, let me see. Good luck with your notes. If I say set E is ABF, it's not correct to say this. You guys agree with me? That is not correct. This symbol, do you guys see why? It's sort of like saying 7 is less than 7. Is that true? Is 7 less than 7? If that is true, holy what? right? 7 can't be less than itself. So E is not a subset of A because they're actually the same. So guess what we do? Bam! It's the same thing. It's the same thing. We just put a little line which allows for it to be equal. In fact, so this is true. E is less than or equal to sort of like, it's a subset or equal to A, but you could also say E equals A. The same way we could say 7 is less than or equal to 7. Are you guys cool with the fact that this is true? 7 is less than or equal to 7. Of course it is, because or means one or the other. Or I could say, amazingly enough, 7 equals 7. Holy crap, right? Okay, so there's a lot of similarities between these subset symbols with less than, greater than, all that kind of business. I like it. I like it a lot. Okay. Let me see, what else did I miss? Blah, blah, blah. It's always fun to go off of memory. Let's see. Okay. Oh yeah, we got to do that. I think I'll do that. What do you guys think? Are you guys, well, what time are we supposed to go to?
20.
20?
We got 20 minutes.
We got 20 minutes. Let's see. Let's do one more thing. And then we'll head out nice and early and you guys won't get used to it. I'm going to erase all this. Here we go. Because I've got a video. The nice thing is, in the semester, I'm going to stop. Most of the days, I'm going to show you videos of young people working on problems. And then we're going to discuss their thought process and kind of like what went wrong, what went right, what would you say to them with the mistake they made, right? So, and we're going to get used to, you're going to be, there's some of them that show up multiple times, and you're like, oh yeah, it's this guy. Right? Oh, we like that guy. He's neat. Anyway. So that's going to happen. There's an idea that's coming up right now that I want to show you a video, but I don't want to do it today yet. So let's talk about this instead. What does this mean here? The set W, let's say. Actually, I'll tell you what. Let's do this. Yeah. If I say the set N is 1, 2, 3, ... What does that mean?
And so on.
And so on. So is this a finite set or is this an infinite set? Infinite set, because it doesn't end. That's what the ... means. Yes? And in fact, I just have to have enough here to show, what do you want to call it, Jeff? A pattern. So if I said set E is this, there's enough there to see the pattern, correct?
Yeah.
And obviously E I chose because it's even. Ooh. Okay. I like it. And of course, why did I choose N here? Anybody know?
Numbers.
What kind of numbers? Natural numbers. So we call them natural numbers because they're what come naturally to us. You know, 1 finger, 2 finger. Do you guys know there's civilizations that did not have the concept of 0?
Yes.
Do you guys know that? So later this semester, one of my favorite things to do, later this semester we're going to talk about different numerical systems like Babylonian numerical system, Mayan numerical system, which is somehow based on breakfast. The Mayan numerical system. We're going to talk about ancient Chinese numerical system. Holy shit. We're going to talk about what base is our number system based on. That's a weird question, but when do our numbers roll over? When will this phenomenon roll over? 1, 2, 3, 4, 5, 6, 7, 8, 9. Then it would roll over to 0, 1. Yes? Our number system is based on 10. For some reason, I have no idea why. Yes? Because, of course, what's the first thing that we would do if we start to get to the point where intelligence is enough, we can kind of keep track of things, is we're going to use what's right here. So if we actually were born, don't take our thumb away because then we don't evolve. If we were born without pinkies, our number system would be based on 8. Our numbers would go 1, 2, 3, 4, 5, 6, 7, 10. So later this semester, we're actually going to work with that. And while I'm talking about this, you might think, why am I doing that? Because I'm not going to do that with my students. You could in some situations, but the bigger idea is you want to feel the way your students feel. When you teach them, if you're teaching 1st, 2nd grade, 3rd grade, you're teaching them some of these concepts for the very first time ever. So if I give you base 8, and I say do some stuff with it, you're going to feel like them. Because you're going to have to stop and think. It's sort of like when you're first learning a language. I can't just talk and I got to translate as I go, correct? All right, I like it, maybe. Okay, enough of that, Jeff. What about whole numbers? Who remembers what whole numbers are?
No decimals?
Good, no decimals, more than that. No decimals. The next one's going to be integers. So whole numbers adds to natural numbers, and this is beautiful. What does whole sound like? Sounds like H-O-L-E, a whole, right? So what number does the whole numbers add?
0.
Freaking 0. Kick ass. And like the Babylonians were a civilization that came up with the concept, not the concept, but the notation for 0, not too far from when their civilization ended. So it's like, look what oh shit, that's up. We're done. But it's interesting. So there were civilizations that had no zeros, which is a little freaky, right? What about the integers? What are they all about? What do they add the idea of? Anybody remember? Integers. So let me ask you this. Caveman got one rock. Yes? I lose my rock. I need to come up with the idea of 0. I borrow a rock. What idea do you need when you start borrowing money and stuff?
Minus.
Negatives. So now it's kind of like, is this more infinite than this? No. They're actually the same size, which is really, really weird, but they just are. Too bad. What about this one? Is this the same size as this? Yes, they are the same size. If you don't believe me, you can create this by doubling each of these. Yes? Double 1 is 2, double 2 is 4, double 3 is 6. So don't they have the same number of elements? Okay, I don't know if you guys are really with me. If you think about that too much, it'll keep you up at night. Okay. Okay. I think that's it. I can feel better about letting it out. I just want to talk about, this came up earlier. And then, of course, there's the rational numbers, but we're going to focus on them when we get to fractions. I think otherwise that's enough for today. Let's go ahead and stop there. If you need to, come up and ask me anything, or if you need help with something. Otherwise, I will see you Thursday, and I'm going to post this video later today.
Thank you very much.
Anytime. Especially Tuesday and Thursday.